Good morning, everyone, and welcome back to another episode from Scale Up Thursday series. My name is Rashmita, and I'm the event planner for Microsoft Reactor India. Today, I'm here joined by our very own host, Vivek and Vinayak, and of course, our special guest speaker, Yarun. But before we start today's session, I would request you all to read our code of conduct. We are all here together to learn, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speaker will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, thank you all. Enjoy your session, and let me bring Vivek into the stream.
Hey Rashmita, good morning.
Morning, Vivek. Over to you.
Thank you. Hello, folks. Welcome to Scale Up Thursday show. And I'm Vivek, Senior Cloud Advocate from at Microsoft. And I have Vinayak with me. Vinayak, bringing in Vinayak. Hello, Vinayak. How are you?
Hi Vivek. I'm well. So my name is Vinayak Hegde. I'm the CTO in residence at Microsoft for Startups, and I work very closely with startups at different stages across the world to help them scale their product and tech. So that's kind of my role. And today we have an exciting startup from Israel actually talking to us about their product called Silverfort. So Vivek, should we get Yaron on the show?
Yep. I'm just bringing in Yaron. Hello, Yaron. Good
Hi,
morning.
good morning, Vivek and Vinayak, and hello everyone.
It's Yaron, just to start the show, right? Basically, if you can introduce yourself with your background, what you've been doing, and how you started this company, when did you start this company, and stuff like that.
All right. So my name is Yaron. I'm the co-founder and CTO at Silverfort. Silverfort is an identity protection company. We built the first unified identity protection platform. Um, I come from a background in computer science. I did my PhD in computer science. Before that, I learned math, and I was practicing cybersecurity for quite a while. And when we started Silverfort, and I started Silverfort together with two of my friends back in 2015 because we felt there's a huge gap in identity protection, which wasn't really a thing at that time, but um, we felt that there was a big gap because we knew how cyber attacks were happening, and we knew that just stealing passwords and hashes were the easiest thing for someone to do. And we said, okay, it just doesn't make sense. What about multi-factor authentication, right? It's supposed to save us from passwords, but we realized very quickly it was much more complicated than that. Um, and we built Silverfort to solve that. Yeah, so that's
Fantastic. I mean, uh, while you talked about how this can be how this can happen, probably if you can share a story like is how can somebody steal a password? If there is a possibility.
Yeah, I mean, that was the thing. We said, okay, we need to protect password because we knew that in real life, when somebody wants to attack a network, what they usually do is they find a way in. Maybe it's through a server, maybe it's through a client, maybe they do a phishing, maybe they'll make you open a file on your computer. Then they're in the environment, and then they do something very simple. They go to the computer's memory, they steal any passwords or hashes that might be there and out there, and then they use these passwords to move laterally, to move to other computers and spread in the network. So something very simple. And already when we started in 2015, there was a very clear solution to passwords, right? It was multi-factor authentication. You don't need only the password to get in, you also need something else, maybe an approval from your phone,
Perfect. So you did introduce us to the journey, like you had background with a cyber attack, and you worked with your friends, and you understood there is a lot of challenges in terms of security, and you wanted to build something through this, right? So let's get started with how did you build this solution, and what was the first set of problems you wanted, first set of challenges you wanted to solve in the Silverfort?
Yeah. Um, so that, like you said, that what we wanted to do is to bring these, the solutions like multi-factor authentication, but were fully available. And I mean, Azure AD was still, something to protect the Office at that time, but it was new. But you had multi-factor authentication mostly in cloud-based identity providers like Okta and Ping for an on-prem identity provider. Um, and all these modern IAM platform had multi-factor authentication, and it stopped attacks, but it didn't stop attacks where the attackers were acting. And these were the interfaces that we found there was a big problem with. Organizations had legacy applications, right? They had a lot of legacy third-party applications, homegrown applications they developed, and they were built to use password-based authentication. They weren't built to use multi-factor authentication. That's still the case with a lot of organizations. They have a lot of legacy applications they need to protect. We have something that every organization has, which is remote admin interfaces, right? You have administrators, they need to access computers, if it's Linux machines or Windows machines, and they use all kinds of interfaces to access them. Now, attackers, apparently, they also using these interfaces because they give them a lot of privileges on the target machine, right? But absurdly, the most important interfaces that everybody needs to protect if they want to protect themselves from a cybersecurity attack, and that's their go-to solution for attackers, just didn't support multi-factor authentication at all, right? You had no way to add multi-factor authentication to PowerShell or to PSXX or to a WMI interface. It was just all doing runners. It was just not existent when we started. The third one is service accounts. Right? With service accounts, it's much. There's no human being to approve multi-factor authentication, right? Today with GPT-4, maybe I don't know. Maybe they're already able to approve themselves with multi-factor authentication, but there's an inherent problem with protecting service accounts because they basically only have the password. And then we needed to find other ways to protect them. You got legacy protocols, file shares that are, targeted by ransomware. You have industrial and healthcare systems. You have a IT and other network infrastructure. So all these were not covered, and that's the problem um, that we were trying to solve.
That's interesting actually, because especially I think machine to machine interfaces. I think it's very hard to do multi-factor, right? Multi-factor it's easy when humans are interacting with machines, and also I think so many of the legacy protocols also, they do not have that notion of you need to have another factor, because you have to modify legacy code, and maybe many times you do not have access to the legacy code, or the vendor is not kind of amenable to changing that code. So it's a real big problem, and especially if the applications are like enterprise, or like like power stations, or those kind of infrastructure services. It's very likely that they will just work on basic, or because the technology there is not like cutting edge. Probably I think web apps and other things that we use like on a daily use may have MFA, but yeah, that's a really big issue, that you said. And I think when I'm talking to startups, I think another major problem is, I think many of the service accounts also have default passwords, right? That is another huge issue that you have, right? So or even if there are passwords, right, which are not default, right, like the passwords are very have very low strength, right? So they're easy to crack, right? So there are, I think, rules. I mean, many of us know the rules, but I think very few people even today actually use like password managers, for example, or having a different password for every account, and that increases the attack surface for any attacker.
Right. I can't tell you how many times you know, I saw an organization that had this one service account that was like security team, or IT team service account, something like that, and they just used it on each and every one of the applications. It had an easy password so everybody can remember it, and it was also used not just by application. It was also used by humans, right? By the IT team and the security team. So it was all over the place, and that's a huge risk, because it just an attacker just needs to get to one place in the organization,
Hmm.
steal that service account credential from any computer, really, because it operates everywhere, and then use it to do anything. And you can't even start to understand how the attacker got there, because it's just it's just the service account is operating everywhere. So that was a big problem.
So, I mean, I have one question. So, we are talking about the MFAs and other things, but what about the key-based, uh, authentication?
The key what? Sorry.
Yeah,
So,
yeah,
The,
so
the
authenticate using like
securities.
PKI. Yeah.
Yes. So that's. But you mean PKI, or security keys and stuff like that?
yeah, security key. So most of the things like from a service to service connections, right? For example, I'm connecting to a database, and I would use some keys to connect, or I'm using an API. There are a lot of API, open APIs, which is there, and I use it through keys, and there is no authentication happening apart from that key, which is there.
Right.
And how does that protection of that key works, and you know how do you protect it?
Yeah. So it's very similar to how we protect password, and that, I mean, I didn't touch how we work with service accounts, but our approach with machine accounts is just first to, it's not only machine accounts to using keys, but a lot of it is machine accounts. And the way we approach it is first you need the visibility, right? So we show our customer what are the service accounts, and that could include managed service accounts that everybody knows that they have them, but it always includes also accounts that are not full non-human accounts that are hybrid, that are used by machines and humans, Maybe they have a regular Active Directory user account created for that. So we give that visibility, and we learn the patterns of each of these accounts, right? Luckily, non-humans are still quite predictable. So I think all that is going to change very soon, everything that's going on. But right now, they are quite predictable. They operate uh, in frequencies that are predictable. They work from the same computers. They access the same services and computers. So we built ways to kind of build a baseline for each of these accounts, and then we can understand when there's a deviation from a baseline, and when there's a deviation from a baseline, um, maybe I'll even just it's too many slides to skip to get to that slide, but when there's a deviation from that baseline, we just either alert or block that activity. So it doesn't matter if the service account is using a key, a very strong key, or a password. It will be blocked once it deviates from what it's permitted to do.
Got it. Got it. I'm pretty much interested in knowing the Uber attack. If you can share some insights on that.
Sure, yeah. Um, so I think it was what I found very interested in this attack. So this is just the background for this is that in September 2022, a hacker managed to achieve access to a lot of Uber sensitive systems. I mean, it doesn't seem that they were doing anything with that. Maybe they just were doing it for show. I don't know, but they managed to get in very quickly, take control over all of the cloud applications by Uber. And I think what's very interesting in this attack is that when you actually look at the attack and every step of the attack, the traditional security mechanisms that organizations had no way of stopping that attack. No way. And that was because this attack all happened at the identity plane. It didn't touch the endpoint at all. So what happened was this. First, they accessed the VPN of the organization. They remotely connected to the network of Uber. They just bought a password from the dark web, and then they just tried connecting. Every time they tried to connect, the user got a prompt on their phone, and they just did it enough times until the user finally approved the authentication. That's a very popular way to get in. It's called MFA bombing. So even though they had multi-factor authentication in the entrance to the network, it was bypassed. And now the attacker was in. They were able to, of course, do whatever they wanted inside because they didn't have any multi-factor authentication inside the networks, as a lot of companies do. So the attacker was able to access a network share. He found a PowerShell script there that had that PowerShell script had some credentials for a vault for a vault that the organization that Uber were using. They got into the vault. From the vault, they extracted additional keys, and they used these keys to access all the cloud applications in the environment. So very quickly they were able to get control of everything. They posted some Slack messages saying, "Hey, we have control over your network." People liked it for some reason, but
Yeah, it was I think that is how they also figured out that something was broken. So how do you even detect such a network does such a breach, right? Because once you're inside the network, I mean, all of it might look very much like an insider activity. So is it even possible to detect once you're inside, or like uh,
it is.
yeah.
Let me just jump like a million slides forward. And spoiler alert. Okay, there it is. All right. So this is where we work with Microsoft to block attacks like this. And you asked about detection, but I think that's uh, that's one of the things that is not enough in attacks like this, because this happens very, very quickly. Even if you're able to detect this attack very early, it might be too late to respond, because
Okay.
once there's an actual person getting into that and responding, it
They may
takes
already access resources. Yeah.
yeah, it takes time, and then the hacker might have already achieved access. It's important to be able to detect and respond to attacks, but detection is only part of the story. And we try in Silverfort to have, for anything we detect, also have a prevention mechanism, and that's key for our protection. So first part, MFA bombing, right? So with MFA bombing, Microsoft has a very cool feature for in Azure AD, that it's called number matching, where you just when you try to log in, you get a number, and you need to enter that number in the phone. So with MFA bombing, it just doesn't work because the user doesn't know the number, right? The number that the attacker gets on the VPN. So it's just a very simple way to block MFA bombing, and this is so this is something that we're enabling in Silverfort, so we can enable that form for any form of application, any service, anything in the network, even things that don't support Azure AD by default. The other thing is to suppress these prompts, right? After the 3 times that the user denied multi-factor authentication, we don't need to ask them again for the same service, from the same IP address, from the same computer. We already know that's part of an attack. So why are we why are we still asking that person, is it you? Is it you? Is it you? No, it's not them. So what we do in Silverfort is simply suppress these prompts. Stop asking them, and stop asking the user. Then they access a network share. Network shares normally don't have a way to add add multi-factor authentication, but with Silverfort, there's a simple way to do it, right? So we can enable Azure MFA for network shares, right? And then even if the attacker got in, when they try to access that shell to get that PowerShell screen, they will be blocked with multi-factor authentication. So again, we can use here number matching, but we can use any form of authentication to block that access. Then
Cool.
they saw this. Sorry.
Cool, cool. I mean, that's great. I just wanted to kind of move back a little bit. You were explaining. Sorry, I broke your flow because I was just really curious. How you can actually avoid the security attack, because this is such a unique attack. And again, like in spite of having MFA, like we always think that MFA in some sense will protect us from everything, and this kind of tells us, okay, I mean, even NFA has its weaknesses, and the weakness is also, as is usual, generally human, right? Which is also the true in this case.
Yeah. So regarding detection, that's an interesting interesting thing that you can like you said, this is a unique attack, right? So if you have, you can have all the agents you want, all the computers in the environment, but you won't see the attack because this attack didn't touch any computer in the environment, right? It only used servers, shares, and cloud applications, not just not workstations, right? These were not involved. And then, but in the identity layer, a lot is going on. You see repeated prompts to authenticate to the VPN. You see multi-factor authentication getting denied. You see an authentication event to the network shell. Then you see an authentication, but by a service account that is usually not used from the VPN, but now suddenly it's being used from the VPN to access the secret server. And then you see a massive authentication to all these massive amount of authentication to all the different cloud applications. So from the identity perspective, there's a lot we can see here. And what we've done with customers that that got attacked, we were able to draw the entire progress of the attack just by looking at the authentication event. We saw how the attacker got in, where where they went from there, what they tried to target, where they failed, what's the where they were able to bypass multi-factor authentication, and where multi-factor authentication was stopped. So we built algorithms to detect these kinds of attacks, and we also know how to how to analyze these identity aspects to these attacks.
Cool, cool. So yeah, I was just saying that we could kind of restart where we were talking about the Uber attack and maybe move to the slide after that so that we can go with the flow that you were presenting initially.
All right, all right.
We talked
Yeah,
about this.
we talked a little bit about how we started. I would just say that it was it was really a kind of a learn as you go experience, because we were when we started the company, we knew we wanted to protect authentication, but we really didn't know how. So, and we had a lot of iterations. At the beginning, we said, okay, we'll do something with hardware. And we went with that to investors, and they said, "What, are you crazy? You're going to start a hardware startups? You startup, you know how hard that is? Don't do hardware." Okay, we won't do hardware. We went and we said, okay, now let's just ask our customers to install agents on all of the computers in the environment, and then we can protect authentication that way. We went with that idea when we talked with potential customers, and they said, "What agents? You know how many agents I have on my computer? I'm not going to add a single one to have multi-factor authentication. Forget about it." So we got agents out of the way. Then we said, okay, let's put a proxy, right? We need to protect these servers somehow, right? We need a proxy. So we talked about the proxy for with our customers, and they said, no way, no proxy. We don't want, if something happens to the proxy, then I get blocked. I don't have access to the application. Someone can get around the proxy. I don't want a proxy. So we said, okay, now we need to figure out a way to add MFA to add anything without, without agents, without hardware, without proxies. Um, what do we do? What do we do, right? So eventually we figured out a way to do it, and that was. It took a while. It took a while. It took, I think, about 6 months after we raised, after we raised money to build a product, until we figured out a way to do it without agents and proxies, and really to do it seamlessly. But the iteration process of talking with customers, seeing what doesn't work, and then figuring that out was very important. And I think that's part of the reason our product is popular today.
Yeah, I think, and people who are in, the audience who are watching this, and if you're planning to build a startup, I mean, there's a very interesting information being provided by Aaron. You go and talk to customers, potential customers, try and figure out what is the best way to solve their problem, and very interesting. You had to go without agents, without hardware, without proxies, and all the things, and try and figure out. You spent almost 6 months to get it done. So interesting information being provided. Just take a look at that as well. So go ahead, Yaron. I just wanted to make sure that audience get that point.
Yeah, I think the interesting was like the fact that you pivoted the idea. I mean, the idea in some sense will remain the same, but the methodology of doing that changed quite a bit, right? So
Right.
especially early stages, you have to do that. Yeah.
Yeah, we were pretty consistent with staying about, I mean, solving the problem that we started with,
Hmm.
which was good. I mean, you need some kind of
Some kind of
anchor
anchor. Yeah.
to remain stable, right, in a company. But the technology, I think it was good to have that iterations, and it was painful at the time, to restart development and to build something completely different than what we started with, and to tell our investors, hey, we're doing it completely different than how we started. So it was painful in the beginning, but I think that's where, as a startup, if you want to remain competitive, you need to have something that others don't have. And that technology that we developed to solve all these challenges, all these problems that our customer has, is what gives us the competitive edge today. Um, so yeah, uh, regarding the system, I think I touched it and touched it previously, but the idea is that we use the IAM platform, right? We use, maybe I also have animation, oh, nice animation, but yeah, we use the IAM platforms, things like Active Directory and Azure Active Directory, and also other identity providers like Okta and Ping. And we use ADFS and Radius, and we work with the different PAM vendors. But the idea is that there's already an identity infrastructure for every company, and that identity infrastructure is in charge of authentication. So we said, let's work with these identity vendors. Let's build partnerships and integrations with them, and then we can add that security layer on top of the identity infrastructure. And it's a unified security layer. So it doesn't matter if the user is authenticating to a file share that's on-prem in Active Directory, or if it's using Okta for a cloud-based authentication to an application. For us, it's the same user, and they're doing an access in the same organization. And the idea of the product where it sees everything. It sees all the authentication, no matter where it is. And in terms of architecture, we built it to work both on-prem. We even have some customers that have completely air-gapped networks that we protect, and we're able to work in the cloud for customers that are cloud first, that want everything in the cloud. We also know how to work from the cloud. So that's a way to do this solution, kind of a hybrid, have multiple deployment, which is always a challenge, but it also gives a lot of flexibility to customers.
Okay.
Um, so you asked to talk a little bit about the team. So we have the team is the people we're using here in the picture. We had the opportunity to have everyone in Israel not long ago. It was great. We brought the entire company in. So I don't know if we'll have a lot of chances to do it again as the company grows, but always a good experience. We have a global team, right? So we have a lot of presence in the US. We have a lot of presence in Israel, and we also have reps in Singapore, in Europe, in Australia. So we're a global company. The tech team is entirely in Israel. So all the R&D is in Israel, and we were just voted in 2022. We were selected by Dance 100 to be the best startup to work for in Israel, over 100 employees, which was a great recognition to receive. Just the team is so we have a few groups in the technology team. We have an R&D team, which is in charge of building the product. We have a product and technology alliance group that is in charge of giving priorities and planning what the product will do, how it will look like. And we also have a team we call Team Cyber, which is doing strategy and research and innovation, and
Okay.
also uh, and also in charge of cybersecurity, both internal and
Okay.
external. Um, uh, that's it, and yeah,
So do you have a team of hackers who test all of these things?
yeah. Yeah, so that's part of Team Cyber. So it's so part of the team we have security professionals and we have data scientists. So the security researchers will look at all the emerging threats, right? When there's a new CVE that's published, or when there's a new form of attack or an interesting attack like Uber, our security researchers will study it. They will try to simulate the attack. They will figure out how to run it, how it works, understand it really, really well, and figure out how the product can block it or detect it. And also, they're doing their own research to find new vulnerabilities in products, to just to improve how we work as an industry. So they found some pretty cool vulnerabilities in several products. And then we also have a data science team that, once there's a detection, there's a certain way to detect a threat. The data science team is able to look at all the data of customers that are sharing data with us, and they look at the data and they see can we see it in the wild? Can we see that threat targeting our customers? And also, how do we make sure that we detect the threat accurately, right? Sometimes there's false positives, right? How do we get around these false positives? How do we make sure that when we give an alert and we say, hey, there's an attack on this on the organization, we're certain that it's an actual attack. So that's part of the work we do at Team Cyber.
Perfect. So, Yaron, can you share a little bit of use cases, customer use cases, for the audience as well, so that they get to know what are the things people are getting attacked and how
Yeah,
Silverfort solves that problem.
sure. Let me see if I have a slide about it. No, I don't have a slide about it, but I will talk about it or maybe over this slide. Um, so our top use cases are adding multi-factor authentications to systems that didn't support it previously. That's a big deal. And protecting service accounts. So these are the top use cases. Um, Now, we also have other use cases, things like, maybe I can go here. So this is used to stop ransomware because these two security controls, protecting service accounts and ending MFA, is just things that just work against ransomware, because ransomware, in order to get to all the computers in the environment, it needs to spread, and that stops the spread of ransomware. Um, we also have customers that want to transition to the cloud. They decide they want to be a cloud-first company, but then they have a big infrastructure on-prem. Right? They have their infrastructure on-prem. They have Active Directory, and they want to use all the security controls that they get with Azure AD, for example, right? And they want to move all their workloads to Azure or another cloud provider. And then what they do is they use Silverfort to bridge their existing infrastructure to the to cloud-based identity. So that way they can take their on-prem Active Directory infrastructure, and instead of doing a huge project, which usually takes years, to move authentication for each of their systems to the cloud, what they do is they can lift and shift, right? They can just take their workloads there, take their infrastructure as is. It works with Silverfort with Active since it works with Active Directory, but then we are able to secure all of it, everything that's sitting on prem, or everything that's moving as is to the cloud. We're able to connect it and secure it with Azure Active Directory. So just in one click, they're connecting all their infrastructure to Azure Active Directory without the need to really change the way the applications are working, change code, sometimes even replace systems that what they're working with. They don't need to do all that. It becomes a very simple transition instead of a years-long project.
Got it. So there is a question which has come in.
Yeah.
Um, so the question is from Vishwa. So basically, RAM bleed has been one of the threats that can be unnoticed. And are there any use cases your team is working on? I'm not sure what exactly is that attack, but yeah,
So I'm not familiar enough with the Rambleed attack to know. So or I can try to read about it after, and I'd love to answer that maybe in
maybe
another.
Vishwas, if you can just share what exactly the attack is, probably we might, you know, answer that question. Anyways, yeah. So Yaron, you when we discussed, you did talk about the partnership you have with Microsoft. Could you share some information, some insights on that as well?
Yeah. So so Microsoft is really key to the success of Silverfort. We our approach very early on was that we knew that the identity infrastructure of a lot of organizations is centered around Microsoft, right? Because of Active Directory, and today because of Azure Active Directory, Microsoft is a big part of the identity infrastructure, right? Even if you use MacBook and Linux, most big organizations are going to use Microsoft technology to protect their identity. And some customers say, okay, we'll compete with some vendors say we'll compete with Microsoft because Microsoft is also trying to protect the identities. But our approach was always to collaborate with Microsoft and build a product to protect the things that Microsoft is struggling to protect. So we were working. We were part of Microsoft for startups, and we've really built this solution together with Microsoft. We've worked with the product teams. The system was tested by Microsoft. It is recommended to customer by Microsoft, and we're continuing to build integrations with Microsoft technology. It started with Active Directory. We continue with Azure Active Directory. Now we've built a very cool integration with the Defender suite, right, with Microsoft Defender. So we've built all these integrations, and it transformed from, and we're running on Azure, by the way. So we use Microsoft technology internally, and we also integrate with Microsoft technology to protect identity. So that partnership is very important to Silverfort, and it became more than a technology partnerships. It is also a business partnership today. Our customers can purchase Silverfort from the Microsoft Microsoft Marketplace, and we're working very closely with the Microsoft team um, to enable and to provide our joint solutions to customers.
So, Aaron, you mentioned that you use Azure internally. So, what all services you use in Azure?
So the first thing is that our production environment is built on Azure, right? Um, so we use all kinds of all kinds of services for our our production infrastructure, um, and uh, and also we are using Azure Active Directory. We are using I don't know if I want to get into all the different to the specific services that we're using in Azure, but I will say that we're using probably almost everything. I mean, you can use everything, but we're using probably one of each thing that you can imagine a technology startup would need for for the infrastructure
Got
in
it.
Azure.
Got it. I'm actually curious to see a demo of this. Like, how does it look? How a customer will look into this, and what are the things you can do on your platform, and how to get started with your platform and other things. If there is a possibility of showing all of these things.
Yeah, sure.
And also, Yaron, if you can tell us, like, if you had any specific challenges, as you're building the product, maybe in terms of, choosing a good technology stack, or, in terms of scaling as well, right? And any lessons, for maybe other entrepreneurs that could be a takeaway, especially with regards to scaling, right? Because you have grown from a, small team to over 100 people, right? So both from a processes point of view, or securing, and you talked about securing your own infra, or even I would say, scaling up your different parts of your stack as well. Any specific interesting examples that you want to take us through, and then I think we can quickly jump to a demo and end with that.
Right. So um, so yeah. So regarding scaling the product and the technology challenges that we faced building it. So this was a hard product to build. It took us a while to bring it to the maturity level that we wanted, because we were trying to solve a problem that was unsolved when we started, and it wasn't unsolved because people didn't care about the problem. It was unsolved because people tried to solve the problem and failed because they didn't have the technology to solve it. So overcoming these challenges just first required a lot of innovation. They required doing things differently, sometimes even doing things in a way that an engineer would normally look at you and say, you must be crazy for doing it. This is not the way to build it, right? So we had to make some hard decisions to build the product the way we did. And then we work very hard and very close to the customers to make sure that it works well, right? So we've invested a lot in QA, right? QA is a big part of how we build the product. And we've invested a lot in figuring out the right development cycles to build the product in a good way, in a way that when we know that we release a product and we when we ship it to customers, we know that it works well, right? Because at the end of the day, we're touching a very, very sensitive piece of infrastructure for our customers, right? The identity infrastructure always needs to be available, right? So we had to make it scalable. We had to make it stable. We had to make sure that it works well for all of our customers. So it took a lot of efforts and a lot of um, investment from an architecture perspective, from a QA perspective, from a planning perspective. So about just
Sure.
something that we need to invest in all the time.
Sure. Yeah. Then let's quickly do a demo.
Great. So let me just find. I'll unshare, and I hope I have good connectivity to the demo environment. I'll also give a prayer to the demo gods. Um, Let me just open that up. So while it's
We have
loading, talk something interesting, E or something.
yeah, it's it's interesting. I mean, Vishwas actually shared the paper, Ram Bleed, uh, regarding that threat which he asked a question about.
Okay.
Uh, I I think it is basically what I think you solve, something related to the physical memory uh, attack, right? The memory attack, which is which you talked about, how people can go and access memory once they are inside your network and get all those details with respect to passwords and whatever is sitting on the in the memory, and probably take that and attack proceed with the attack again. As you told, it is not detectable, right? Once they are in, it's like pretty
Mhm.
easy to go and drive it. I think pretty much you're solving that problem, but yeah, probably you can go back and answer Vishwas, once you have read about it, and
Yeah,
share the details with him.
yeah, sure, absolutely. So I am experiencing some difficulties connecting to the demo environment. Luckily, I do have a short record the demo, so maybe I can work with
Yeah.
that. Um, it's very short, but it's to the point, I think. So um,
I think yes, Vishwas. Let me post this question as well while you're setting up. So Vishwas was asking, like, do you find false positives in your tool, and how do you report back to the customers, and how do you handle false positives?
right. So yeah, but that's an interesting an interesting question. So our approach to to detection in general to risk is we try to always have two forms of risk indicators or things that we alert on. Right. One is have something that is very static and it almost doesn't have any false positives. Right. So in almost every attack that you can imagine, there's something that will catch the attack every time, but will get it wrong a lot of times. And there's other detections that you can build that will catch only this attack without false positives, and but it might have some false negatives, right?
Yep.
So we try to build both, right? And the idea is that when you get a false positive, um, we try to reduce the friction that it causes. So, for example, let's say that we have every time that we see a ticket being used outside of the IP address that it was received, right? What's usually called the pass the ticket attack. Every time that happens, add multi-factor authentication. So just because, so this is a detection that will not have 100% success. Sometimes it will give false positives. But what happens if we're wrong? The user gets prompted with MFA, and then they'll say, yes, it's me. So not we didn't warn the entire organization about the pass the ticket attack. We didn't we didn't tell we didn't brought the entire incident response team to start responding to that threat. But we saw that there was a risk, and we asked the user. So the user was able to either approve or deny the authentication. So that's what we do with most of the risk indicators. But then we also have other detections which are more accurate in the sense that they might not be able to catch all of the attacks, but the attacks that they do catch are really attacks that you want to look at, because these risk indicators almost have no false positives. And for these, we will send that information to the scene and trigger an action with the SOC team. So that's our approach to these kinds of threats.
Fantastic. Let's see a demo then.
Yeah, so I just want to show a very quick demo. So here what we have is we have a PowerShell. So I am opening a PowerShell and I'm running the enter PS session command to open a remote PowerShell session with the computer here that's called T5 AWS. It's in AWS, sorry Microsoft. And it's a domain controller sitting on AWS. And you would agree with me that protecting protecting a remote PowerShell session to a remote computer is not something that natively support Azure MFA. But when the user enters that command, what we see is they get the sign in with Microsoft prompt, and then they need to then they can sign in with Microsoft. Normally they get a MFA with Microsoft Authenticator, and then they get in. So very simple, but really the idea is that we will be the first vendor to enable Azure MFA for things like remote PowerShell.
So basically, I have a PowerShell on my Windows, and I'm connecting to the remote. So I would go and enable the multi-factor authentication on this PowerShell, and so that whenever I authenticate remotely to that particular server, uh, or it is enabled on the both the sides, right? So basically, it has to authenticate, and uh, and then I just apply it and provide information, and then I log in. So that's how it is done.
Yes, but the important thing here is that we didn't have to install anything on the remote server, and that configuration that you're talking about is not a configuration of the system, the specific application that we're protecting, right? So we didn't have to touch that, not the client, not the remote server, to enable this, right? So this was just out of the box, and now that I was able to open my demo, maybe I'll share a quick. Maybe I'll share my screen just so I can show you how this is, how this looks like from a configuration perspective.
Yeah, that would be interesting, like looking at it from a configuration perspective, right? Because you're saying that very less needs to be configured, nothing needs to be configured on the client or on the server, which is quite interesting. So yeah, so curious to see that part.
So yeah, so this is our policy screen. What we do is we simply create a policy. Let's call it PowerShell. Here, this is an active directory of authentication. It needs to protect Keybased and NTLM. Here I have NTLM disabled, but let's do NTLM anyway. And then I select the users that I want to protect. Let's say that I want to protect, I can select specific users, or I can maybe select a group of users, maybe all domain users, Maybe I can do only administrators because only they have the privileges to connect remotely to other computers with PowerShell. And here I can select the computers that I want to protect. Here too, I can select specific applications.
Mhm.
In these applications, I can select the in the server that I selected. I can select any service on that server, right? There's a lot of services. Let's just select one. Um, or I can say I don't care. Any service that you work with on that server, you see that there's a lot. Any of these I want to protect. I can
So
also
this is
select.
like a so this is like a proper rule based a policy that gets generated, right? So you can mix and match, and on one side you can have the servers, on the other side you can have the protocols, and then uh, if any of the triggers matches, then that it actually throws you a prompt so that you can
Exactly.
authenticate. Awesome. So it's
Exactly.
completely rule based. Yeah.
It's
But
rule
how
based, but
does the
also do a risk based policy, right?
Okay.
And this, for example, can work with things like a Microsoft Defender, right? Maybe I get a signal from Microsoft Defender for identity that says they detected pass the hash attack on this
Hmm.
user. So now I'll add multi-factor authentication based on that risk.
Okay, so you can take third party signals as well, and then that can have a gradation by itself. Oh, that's pretty
Right.
cool.
Yes, and we have our own signals as well.
Sure.
And so here I can add, any multi-factor authentication factor that I want, right? We work with a lot of them, and we're always developing new ones.
so Yaran, just one question there. So how do you get that list of all the services, which is, I mean, like the servers list onto your system?
We get that from Active Directory.
Okay, got it.
Um, so this is so every we get that information about each server, what the services are, which services are available on that server. Um, so we get so we can do MFA, right? Or we can do an Azure AD bridge, right? That's what you saw right now in the demo. With an Azure AD bridge, we'll just send it over to Azure AD, and then whatever you have configured on Azure AD, if you have a conditional access policy, for example, that will
Hmm.
take place, right? So we're the only company that can enable something like this.
Interesting.
Um, so that's the policy, but also you can just open here. I'll just open the logs. You can see that I have just a list of all the authentication I have in every identity provider, right? So I can see here Azure Active Directory authentication for this. This is some kind of service account, and I also have some user authentication in my Active Directory, and I have
Hmm.
all the information. I can filter on it. I can investigate threats this way. And just one thing that I wanted to show really quickly, and we can end probably the demo there, is the service account page. So here's where we detect all the different service accounts. Here I have some machine to machine, machines that are authenticating to other machines. I have hybrid accounts, which are used by users and uh, and also also non-human accounts. I have scanners. These are the most risky ones, right? These are accounts that connect to everywhere. And I have other accounts as well. And for each of these accounts, I can go and I see the list of places that it's connecting from, and the list of places that it's connecting to. And then I
Okay.
can lock it down to the activity that I'm seeing. So it
Okay.
does only what it's supposed to do.
Cool.
Great. Um,
So audience, if you have any questions, just post it
Yeah.
in the chat. Uh, we can
We
ask
I think we're a
Jan.
little over time, but I think we can take a few questions before we end this edition. Actually,
Yep,
Vivek, are you seeing any questions from the audience?
not yet. So it was good. I mean, the bunch of things. I didn't know that you can go and enable MFA on the PowerShells. You know, that's something which is, it's a learning for me as well. Like, I never experienced that, so it's good to see that. And a lot of things, even memory based attacks, and a lot of things which can be solved. And I really liked your UI, which shows all the authentication which is happening, and where the block is happening and everything. So it's
Thank you.
interesting. So there is a question again from Vishwas. Are there any plans to also give out uh, semi solution to silver from Silverfort?
Yeah,
I don't
that's
know.
already available. We do send all the information out to SIM, right? So you're asking if we're going to be a SIM solution? No. So we are not in the SIM business, but we do work with the different SIM solutions, right? So um, all of the
Maybe.
data that you saw in our product can be sent out to a SIM solution, and that's how most of our customers work with the product.
So just for layman, like what is that SIM solution is?
Well, a SIM solution is basically a security system that collects all the security events in the environment. So it collects that information from all kinds of security solutions. So Silverfort here is one of them, right? So we only see the identity context, but there's a lot more information that you want to work with, right? The network aspect, the endpoint aspect, the cloud aspect. So all the information should be sent to a SIEM solution, and then from that SIEM solution, you can run analytics and correlations and figure out what's happening in your environment.
Perfect. Cool. I think mm, we have not got any more questions there. So, Garen, thank you for coming on the show and sharing all the insights on security. Obviously, there is a bunch of things to learn. Thank you for coming on the show again, and thanks Vinayak for being here, and thank you Rashmita for hosting us. Until next time, we will all have more startups coming here and sharing their journey as well. And again, thanks Sharon for being here.
Thank you,
Thanks.
Vivek. Tonight, I really enjoyed the conversation, and thanks for everyone that attended.
Yep. Thank you. See you
Thanks.
all.
Bye.
Bye. Take care.